Okay, good afternoon, everyone. Welcome to our session once again. Today, we're going to continue our discussion on ARIMA, autoregressive integrated moving average. So we were working on the data set that comes with the data sets package, the airline passengers. So let's have a quick review of what we have done last time. We said that this data set is not stationary in mean, but not necessarily not stationary in variance. Looks like constant naman yung variance niya. No? Okay, so constant naman yung variance. Tapos, sorry. Let me pause. Okay, so we said that in order to use ARIMA, kailangan yung model, yung natin time series natin should be stationary. So we have to do transformation here dito sa AP na natin na airline passengers na data. Okay? And one way to in order to detrend this, tanggalin yung trend, we can do differencing, di ba? If you recall, so dito plus I'm creating this object DAP, difference AP, which is the ito yung natin, no? Ang default nito class log is equal to 1. Okay, that's the default. Pag hindi natin linagay log is equal to 1, yun ang default log is equal to 1. Okay, so if I run this, okay, we can see that our airline passengers is now stationary. Do you think we need to do transformation in order to make this? Is the data also stationary in variance? Mean constant ba yung variance natin? What do you think, class? Is there a need for us to get the log first? Kasi di ba hindi pa pwede yung hindi pa pwede yung mauuna yung difference tapos saka natin kukunin yung log. Plus, kailangan pa ba i-log ko muna bago i-difference? Answer, class, come on. Okay. Bakit why yes? Jerome, bakit yes?
Sir, may negative values po kasi.
Yeah,
If you may block.
yeah, okay. I think my question is, kailangan pa ba natin kunin log bago tayo mag-differencing? Jerome? In order to, di ba kailangan linalog natin para ma-address yung non-constant variance?
Yes, sir. I think for this, hindi na po siya need ilog.
Yeah, okay. You're correct, no? So the answer is hindi na. Let me show that again. Kasi tingnan naman yung natin. Tingnan yung plot natin, di ba? Ito. Where's our AP? Plot. Ito klase. Looks like hindi naman constant naman yung variance. No? Okay. Now, kung constant naman yung variance class, you don't have to get the log kasi the more simple the model is, the better. Okay. So perhaps here in this case, no need to get the log, but you can try, no? Pwede nyo naman tingnan. But in this case, anin ko lang na ipa-plot natin yung, sorry, dito na tayo, here. So this one, plot DAP, and then we get here your difference data set. Okay, and it looks like stationary already. Now, we said that before we can model our time series into a using ARIMA, we have to make sure that it's stationary. And there are certain tests that we can use. Last time, ang ginamit natin class, di ba, si augmented Dickey-Fuller test. So this is augmented Dickey-Fuller test. Initially, this was just DF kasi in-improve nila. Okay, ADF test. Now, there seems to be a problem with this one kasi alam natin ito class, pag nag-ADF test tayo ng AP, we know that, okay, take a look at this. No? Ang sabi dito, data AP, ang null hypothesis natin dito is the data is not stationary. Pero still, here, what we're getting is a p-value of 0.01, which means we're rejecting the null hypothesis. Okay? So, ang inference natin dito, stationary yung data natin. Di ba? Hindi naman stationary si airline passengers. Eh. May trend siya. So, that's a problem with the augmented Dickey-Fuller test. So, apparently, class, medyo magulo yung medyo magulo yung null hypothesis. I've seen so many questions about this sa internet. So medyo parang parang nagdi-debate o nagdi-discussion pa. Ano ba talaga yung inaano ni ADF test? May nakita nga ako na ang tinetest ni ADF test is not the data itself but the difference data. So medyo confusing yun. Kasi kung difference yung data na tinetest ni ADF test, for example, ito AP, no? So if what it's testing is the difference of the data, difference ng AP, edi tama itong answer na to. Kasi yung difference ng AP is stationary. Diba? Buti lang may iba pa mga test. No? So you can use the ADF test in consonance with the other tests. If we use the ADF test dito sa difference ng AP, what do we get? We get the correct answer. Okay, this is the difference airline passengers, and we know that this is stationary. The null hypothesis is that the data is not stationary, okay, and then the p-value is 0.01, so we reject this. So tama, i-reject natin to. Kasi yung object natin na DAP, which is your difference AP, is indeed stationary. So for DAP, tama yung ADF test. Pero for AP, hindi siya lumalabas sa tama. No? Okay, so there are other passages, other tests like UR.kpss. Okay, so this is coming from the URCA package, and it's a unit root that Wojcicki, si Phillips, basta apat sila na statistician, no? And if we check this class, kunyari sa AP ang check natin, ha? Okay, if we check this, so what do we have? KPSS unit root test. All right. So ang lumalabas dito, okay, the value of the test statistic is 2.8287. And we compare this with the 5% significance level. The critical value is, annotate natin. Ang critical value nito is 0.463. Ibig sabihin kung, I'm not sure kung ano yung test statistic nito, no? Assume it's t-stat 0.46. Okay? Ang t-stat niya is, ang test statistic is 2.827. So it's here. So nasa rejection region siya, di ba? Nasa rejection region siya. Therefore, we reject the null hypothesis. Ano ba yung null hypothesis dito? That our data, okay, tingnan nyo yung natin, null hypothesis. No unit root, in other words, stationary. So we reject the null hypothesis that our data is stationary. So dun sa UR KPSS test, tama yung result nito for AP. Dun sa ADF that test, medyo hindi, no? And if we use the UR unit root that KPSS test for DAP, okay, so i-run natin to. Okay, so the t-stat is 0.02. Okay, the t-critical is 0.463. So just like our analysis a while ago, analysis natin kanina, ito yung t-critical 0.463, 0.46. Critical value to, no? Pero yung stat natin 0.02, it's here. Diba? It's here. it's to the left of the critical value. Therefore, ito yung ano natin ito yung rejection region. Therefore, for this one, we fail to reject the null hypothesis that the data is not stationary. Diba? Ang null hypothesis natin dito sa KPSS test, no unit truth, aka stationary data. So for DAP, we fail to reject the null hypothesis that our data is stationary, which is correct kasi alam natin na DAP, the difference AP is stationary. Okay, alright, may mga answers dito. Thank you, Vince. Masabi dito ni Vince. Okay, sorry, hindi ko nabasa yung mga answer nyo kanina. Kanina, ito yung question na to, yung yes, yes, yes. I think the question here is, kung kailangan pang i-log yung ano, the answer there is no. No? Kasi if we plot yung AP, di ba, hindi naman, it does not exhibit non-constancy in variance. Constant naman yung variance. No? Okay, so just by differencing, na convert na natin siya, transform na natin siya into stationary data. And then here, no need, sir, it looks like stationary to me. Okay. All right, thank you for your answers. No? Si Vince naman, hindi po pwedeng ilog ang negative. Okay, so this was the answer to my other question a while ago. Kung pwede bang i-difference tapos ilog. You're correct. Hindi pa pwedeng i-difference muna. Okay, tapos ilog. Kasi magkakaroon tayo ng mga not a number, mga error terms. No? Very good. Very good. And one question, class, very quick question. What does a difference log time series represent? Pag kinuha mo yung difference ng log na time series, ano yun, class? What are you actually getting? You're getting anyone? Lawrence, ikaw, alam mo yan. If you get the difference of the log, what are you actually getting? Consecutive values. Consecutive values naman talaga sila, no, Vince? So by getting the log, tapos getting the difference, consecutive values pa rin sila. Pero that's a special value kasi. You get the log and then you get the difference. What's that? That's the Lawrence, ano? I was asking Lawrence. Dapat alam mo na yung Lawrence kasi nasa FINTSAR ka rin. Continuous returns, okay. Thank you. Hindi ARIMA. Could you kindly share your answer? Everyone, please. Yeah, it's the log returns, no? Thank you, Claire. Log returns siya or continuous returns. So pag kinuha mo yung, kunyari, meron kang stock prices, no? Yun, project niyan, case niyan, no? You're asked to get as a company, kunyari sa real estate, top company, kunyari sa Philippines, sa Thailand, compare kasi natin yung ARIMA, tsaka yung guards nila, no? So, if you get, kasi sa stock prices class, ang kinukuha usually dyan, hindi yung prices, ang kinukuha dyan yung returns. So, you have to get the log returns. The way to do it is get the log and then get the difference. In other words, pwede isang function lang yan, no? Kunyari, DLAP, in our case, DLAP is equal to difference ng log of the asset. So yun, that's already the log difference. So you just remove the missing value. Okay? So remember, class, pag kinuha nyo yung log tas yung difference, ano yun? Yung log returns yan, continuous returns yan. Okay. So back to our lesson, ito, no? So you know how to analyze, you know how to interpret yung unitroot.kpss. Okay? Now there's another one, ito Okay, UR.df naman. Unit root dot Dicky Fuller. Ito tama ito, no? Tama ito. UR.df. This is also coming from the URCA package. So ito, ang null hypothesis is that the time series is not stationary. Okay, so let's run this first. So, summary ng UR.df. Unit root that Dicky Fuller. If we run this, okay, medyo may strange na ano, no? May strange na iba yung output niya. Okay. Iba yung output niya. Now, this is very important for us to understand. Okay, ano ba yung model dito? Take a look at this. What's being modeled here? Ito, may equation. Z-diff. Ano to? So yung object dito is the difference data. No? So, kumbaga sa atin, kung AP ang tinitingnan mo, yung difference AP yan, no? Ayan na. Z-diff, the difference data. And we're modeling it on is equal to a certain constant. Let's call the constant rho. And then this is Z log 1. So the AP T minus 1. Okay? And then minus 1 tapos plus a certain constant. No? So ito lang titingnan natin. So ang tinetest dito, the null hypothesis is that this number here, rho, is equal to 1. Yan ang null hypothesis dito. Ganun din sa iba, no? Yung unit root test. Ito ibig sabihin ng unit root test. Kaya unit root test, it means that the solution to this equation is a unit value. Pag sinabing unit 1, yun ibig sabihin ng unit root. So what's the importance of this becoming 1? Now, if this is 1, okay, if this is 1, then your data, the relationship between the difference series and the log 1 series will behave like this. Ganito yung magiging behavior niya. And we call this a random walk. Yan. Ang tawag dyan, pag DAP is equal to DAP sub T is equal to 1, okay, 1 to di ba? Unit root eh. Ang root nitong equation na to, the solution is 1. Is equal to 1 times DAP T minus 1 plus a certain constant, no? This is what we call a random walk. And ang random walk, meandering yan. Hindi mo alam kung saan papunta yan. Okay? So that's what a random walk is. And the random walk has this equation. Yung difference ng data is equal to, or yung kahit hindi difference, no? Yung time series niya is equal to 1 times the log value ng time series, T minus 1. So when your time series can be expressed that way, then definitely that's not stationary. Kasi pag random walk, hindi mo alam kung saan papunta yan, no? Magme-meander yan. Unlike a stationary time series, alam natin na mean reverting. Okay, so ang difference siya, ang random walk, meandering, ang stationary time series, mean reverting. Ano ibig sabihin ng mean reverting? Aakyat man siya, babalik din sa mean yan. Yan. Yung mean, di ba? Babalik at babalik sa mean yan. It's called mean revert. No? Reverting, babalik sa mean. Okay, class? Mean reverting ang stationary time series versus ang random walk, which is meandering. Alam niyo naman, di ba? Ibig sabihin ng meandering kung saan pumupunta, di ba? Right? So that's the difference. Okay? So dito, ang tinetest natin, itong coefficient nito, yung rho. And here, we see that if we go down here, tinan nyo to. Yan. Z.log 1, so this is your DAP T minus 1, di ba? The p-value is, estimate na, no? 0.001, and the p-value is 0.5. Okay, therefore, anong natin dito? Ano yung ano yung conclusion natin? What's our conclusion? Again, balik tayo sa null hypothesis. Anong null hypothesis natin? Na ano? There is a unit root. No? May unit root. Ibig sabihin, not stationary. So, anong conclusion natin? What's our conclusion? What's our conclusion, class? P-value is 0.5. Therefore, we fail to reject the null hypothesis, di ba? We fail to reject the null hypothesis that the data is not stationary. So dito sa unit root that Dickey Fuller, tama yung conclusion dito. That AP is not stationary. And if we run this, yung difference ni AP, run natin using unit root that Dickey Fuller. Okay, what do you have here? Take a look at the P statistic, ito P value. No? Alright? So, ano sinasabi dito? What are we saying here? For DAP, ito, di ba, ang null hypothesis natin dito is there is a unit root, which means that the data is not stationary. Okay? Ano conclusion natin? Ito. We reject the null hypothesis that rho is equal to 1. Reject natin yan. Okay, therefore, what we can say is DAP is stationary. Which we expect kasi ang DAP, di ba? Stationary and mean na yan. Tapos hindi naman siya, constant naman din yung variance niya. Okay, pause muna ako for confirmation from you kung naintindihan. No? So my question dito, Jerome, kindly share your question to everyone.
Sir, I was just wondering how come my code po for the KPSS is different po
Sige, tingnan natin
compared to yours po.
Okay, ano natin, pa-share ng screen, dali.
Ay, sige po, sir. Wait lang.
Stop share ako.
Sige po, sir.
Sandali, hindi ko pa saan na ba yung dali. Share screen. Oops. Where is that? Wait lang. Screen. Okay, wait. Meron. Saan mo yan? Stop share. Stop share then share screen. Saan siya? Hindi ko makita yung make everyone share. More. Saan? Where is that? Participants mo, hindi rin. Dito yung sa share screen. Ayun yun. Okay. All participants. Okay, sige. You may share screen now. Okay.
Ayun po, sir. Is it visible po? This one po, yung KPSS.
Sige nga,
Ito po yung nag-run. Yan po. At the same time, sir, yung sa may DF po, hindi rin po siya nag-run on my end. Ayan po yung output na nagyan. Could not find function.
I-load mo nga muna sabi dito sa console mo, could not find function UR.df. So i-load mo muna
Yes,
Wika. Library ka.
Okay. Sige,
Library. Yan. Wika. URCA. Yan. Okay,
ayan
sige.
Po, sir.
Hiran mo na.
Yan po, sir.
Yan,
Okay
okay.
po. Thank you so
Alright?
much po, sir.
Sige. So tama, no? Tama naman.
Yes po, sir. It's
Okay,
same
good.
na po.
Good, good. All right,
Thank you,
good.
sir.
Sige. Thank you. Thank you for that question. I appreciate really you asking me. No? Ibig sabihin kasi nun, it sends me a signal na you're trying to follow. No? Okay, thank you. Thank you, Jerome. I really appreciate that. Okay, share ulit ako ng screen. Any other questions, class? Okay. So, medyo ang ano na lang natin, yung augmented Dickey Fuller. No? So, sa ano nyo, sa case, gawin nyo pa rin yung augmented Dickey Fuller. Explain nyo na lang na ano na yung kung ano yung tinetest niya. No? Kasi nagko-conflict, di ba? Pag augmented Dickey ADF, that test, pag tinest natin si AP, sinasabi, ano siya stationary. Pero pag ginamit natin si UR.KPSS, hindi siya stationary. Pag si UR.DF, hindi siya stationary. Pero yung UR.DF class, actually, Dickey Fuller din yan eh. So, as I said a while ago, ang daming nagdi-discussion yan sa ang daming nagdi-discussion. Dapat ayusin na lang dun sa gumawa ng augmented Dickey Fuller test para hindi na magkaroon ng conflict na ganyan. Okay, so let's proceed. Okay. Now that we have so di ba ang unang step, kailangan yung time series natin dapat stationary, no? After that, we will have to determine kung anong siya, AR ba yan o MA ba yan o ARMA ba yan. So how do we do that? Before, it was done manually, no? Yung panahon namin. So, mag-create kami ng ACF at saka PACF tapos i-determine namin kung AR process ba yan o MA process ba yan. So, paano natin malalaman kung AR process? Okay? Kung AR process, ano yung titingnan, class? Anong correlation function? Anong correlogram ang titingnan? So, kasi dapat mag-generate tayo ng di ba, ng correlogram. Okay? Yung correlogram, dalawang klase yan, either autocorrelation function or partial autocorrelation function. Okay. Pag AR process class, ang tinitingnan natin yung PACF. Pag MA process, ang tinitingnan yung ACF. Okay? So for example, paano natin malalaman na it's an MA process? If it's an MA process, you take a look at the you take a look at the ACF plot. Yung ACF plot will look like this. So ito yung significance levels, Okay? So ganito siya. Significant spike, another significant spike, tapos wala na. Okay, sorry, lumampas. So ganyan na, no? Meron lang ditong 1 or 2 or depende sa model, may mga significant spikes dito. So this is the ACF. Tapos ang PACF niya, class, ang itsura nun, parang exponential decay. Parang ganito. Hindi masyadong maaming drawing ko, pasensya na. Okay? So it looks like there's an exponential decay. Unlike this significant spike at log 1 or log 2, tapos wala na. Yung PACF niya, parang nagdi-decay lang yung mga logs, yung mga significant logs. No? Now, saan naman? So MA process yan, di ba? MA, ang titingnan natin yung autocorrelation function. Ito. Pag AR naman, baliktad. No? Baliktad. Yung ACF niya, ganito yung itsura. Yung PACF niya, ganito. Okay? So, before when we were solving this manually, medyo mahirap for me, no? During that time na nag-aaral ako. It takes time. Matrabaho kasi iisa-isin namin yan eh. Diba? Manghuhula kami, AR1 ba to? So, sige, run ng AR1, plot ng solve using AR1. or MA. Tapos magko-compare ka, ano ba, AR1, MA1, ARMA 11 ba, etc. So it's quite a long process. No? Pero ngayon sa inyo class, ang dali na kasi the presence of R makes it really very easy. Okay, but let's now plot the parallelogram. No? So pagsama na lang natin dito, partition, yung row natin, si 1 row and 2 columns. Okay, so i-plot natin si ACF. I'm creating this object, ACF.DAP, which is just the autocorrelation function ng DAP. Lagyan lang natin ng title. And then log.max, itin na 36 yung log. Of course, pwedeng lower, pwedeng 12, pwedeng 24. Arbitrary naman yan. Okay? Anong advantage? Wala naman. Kasi usually pag matatagal na yung mga log. Kasi pag log 36, ibig sabihin, titingnan din niya kung may correlation pa yung time t at saka time 36. Usually naman, unless it's really a strong seasonality. No? Okay, so i-run natin to. And then we see this. Ang problema lang nito, pag hina-highlight mo, show in your window, nawawala yung isa. Kaya nyo to. I don't know kung ano yung nito. Tapos yan, ima-maximize ko Hindi. Hindi pala. Kanina nawawala Okay, take a look at this class, ACF. Di ba sabi natin, pag ACF medyo, medyo magsasabi to na MA siya. So may mga significant spikes tayo dito. Significant spikes. Pero parang exponential decay siya, di ba? Parang gumaganto siya. No? So ang hirap ma-determine, ang hirap. Tapos dito sa PHCF, ay, mali yata yung title ko. Ba't dalawa to? Sorry. Mali yata yung ko yung, ito. Kaya pag mali ito. PHCF. Ulit. Yan, PHCF. So, if we're going to use this, yung ACF at saka PHCF, in trying to model, nawawala yan. Minsan nawawala yung yung pangalawa. Yan, pag yan. Anyway, yun na lang. So, medyo ang hirap ma-determine. Yung nasabi ko sa inyo na class na na pahirapan malaman kung ano yung model based on the ACF at saka PACF. Kasi medyo hindi apparent Di ba? So, ang gagawin natin, buti na lang meron ng auto.arima si Okay. By the way, another way to do it is ito, using the TSM package. Ito kasi dinadalawa pa, ACF at saka PACF. Ito isa na lang, autocorrelation. The AP main is equal to that one. So that will give you also the same plot. So isang code lang sa isang plot, no? So that's the advantage of the autocorrelation function with TSM. Okay? All right, pause muna ako class and ask you if so far naiintindihan yung concept. I-summarize ko lang. Pag na-convert na natin into seasonal stationary data, i-plot natin ACF at saka PACF. Anong objective nun? Para malaman natin kung AR ba siya o MA siya. Sabi natin, how to determine if it's an MA series, MA time series siya? By looking at the ACF. Pag may mga significant spikes sa ACF, then it's a signal na na MA yan. MA, significant spike sa ACF, pero sa PACF, slow decay. No? Ito parang slow decay siya. But it's hard to tell, no? Kasi dito, tapos dito naman, hard to tell. Pero it can be indicative na MA siya. No? Pero dito may mga significant spikes siya dito. Dito sa this indicates that yung seasonality yan. Okay, so sige class, mag-ano na tayo? Control Alt I. Hindi. Sige, let's do what we did in the other section. Okay, manghula muna tayo. Manghula tayo, class. No? Sabihin natin na simpleng model muna. What about making this an ARIMA 100? No? Ito. So what we did in the other section was, trial and error. No? So mag-create tayo ng object na ARIMA 100. Okay? And the function is ARIMA, and then the object DAP, and then ito order is equal to 0, 1, order is equal to C, 100. So you're telling R to generate an ARIMA model, an ARMA 100, an ARIMA 100 model. And then i-summarize natin. Okay, so yung DAP na object na time series, sabi natin kay R, gumawa ka nga ng AR1 model dyan. Okay, so i-run natin. Hey, take a look at this. Ayun. Diba? So if this was an AR1 model, then ang equation natin will be DAP natin para dapat marunong tayo class mag-generate ng equation. Okay. If assuming that this is really the model, so ang model natin DAP, di ba? Kasi ito yung time series natin, no? DAP sub T, okay, is equal to a certain constant which is 0.0097, okay, plus 0. Plus, okay, ito yung AR1 component, no? 0.1997 times DAP T minus 1. Diba? Autoregressive, no? We're using DAP itself and log 1. And then plus an error term, epsilon sub T. Okay. So that's our AR1 model. Okay, pause muna ako. Please chat if you were able to get this. Paki-chat please kung okay itong model na to, kung naintindihan yung pag-generate ng equation. Assuming na tama itong model na to. Assuming that this is the model that we want. So we're modeling DAP, di ba? Yan, no? Kita nyo, ARIMA ng DAP. So DAP sub T, that's our sub T is our time series, is equal to 0.0097, which is your intercept, plus 0.1997 times yung AR1 component is DAP times T minus 1. Kung may AR2 yan, then DAP not times, sub T minus 1, and then sub T minus 2. And then plus your an error term. Okay, paki-chat naman please kung nakuha, class, please. Of course, para ma-immortalize yun, di gawa na lang kayo dito ng okay? Para dollar, para ma-record nyo rin. Kasi baka, siyempre, pag inaaral nyo to. So that's DAP underscore, that's T, is equal to 0.097 okay, plus 0.1997 times DAP underscore curly brackets T minus 1, okay, plus epsilon or E underscore sub T. There. Okay, so that's your AR1 model. Okay, pa-chat naman please kung clear. Pakian lang para medyo may confidence ako na nakukuha yung model natin. Appreciate your feedback, class. Epsilon, sakti natin yung error time natin. Okay, good. Ano pa lang nagko-confirm? How about the others, class? Dami natin, 20, ano tayo? 27, 25. Okay, I'll wait for the others to give their feedback. Okay, thank you. All right. So, yan na ba yung model natin? Well, we don't know. Sinubukan lang natin, ano? Ha? Different data set ba? Bakit, Jerome? Class, magkakaiba ba tayong answer? Airline passengers to.
I'm not sure po, Sir, pero I'm with my friends po, pero same po kami ng results, pero different
Talaga?
videos.
Okay. So, pero yung AP kasi, galing sa ano, di ba? Galing sa data section.
Sir,
Okay, yes?
sir, I think yung DAP nyo po, it's different kasi yung DAP nyo po puro decimals yung answer. I think whole numbers po sila dapat since it's just the difference of whole numbers din po.
Oo nga. Ganun ba? Wait let me check. Okay. Sorry kung ganun. But importante yung ano yung proseso Okay, sige. So ano na lang, don't mind the values. Ibig sabihin, dali, head DAP. Oo nga, bakit nga pala bakit to? Yan, you're correct. Kaya pala medyo matagal kayo mag head AP. Oh, tama naman. Wait. Bakit decimal yung ko? Yung AP ko? Nalog ko ba to? Wait sorry class. Wait, let me just check, no? Parang nakalog siya. Okay, data. Air passengers, no? Okay, so andyan siya. Andyan na si air passengers. Okay. Ayun mukhang iba nga, iba. Oo, yeah. Sorry. So, okay. Apologies, class. Okay. Sige, babalikan ko quickly, para AP. Okay. Para just to check, Kaya pala parang AP. Ayusin ko na lang sa akin, Okay. So if I check head nito, wait. So may AP na dapat ako. Ayan na. So ang AP ko ngayon, bakit nagaganto pa rin? Okay. Wait, tanggalin ko muna si ang gulo tong AP na to. Tanggalin ko si AP. Yan. Wala na si AP, no? So AP is not existing anymore. So if I download AP, nandiyan si AP. Wala. Wala pa rin. Hmm. Wait. Bakit ayaw mag-create si... Yan. Okay. Oy, hindi. Naging ano siya, naging character. Okay, sorry class, sorry. Yan. Hindi yun. What's happening? Bakit ano? Okay. So, oo. Kasi may airline passengers, air passengers at tayo dito, ano? So, if I remove this, ayan, okay, sorry So, AP ngayon, head AP, tama na yan. And then, if I difference, DAP is difference ni AP, control enter. So, hold nito, shift enter. Okay, yan. Tama na to, no? Tama na to.
Yes,
Kasi,
sir, same na po.
ayan, sorry sorry. So, tama kayo, no? That's why, no? Okay, so I'm now using yung DAP na ano. So, let me redo this. So, balikan ko to. Nung nag-ano tayo, yung nag-unit root test, ito. AP, tama ba ito nakaano? ADF test. Mali doon, ano? Pero itong DAP, tama na. Tapos itong, binabalikan ko lang klase, itong KPSS test, okay, 2.7, okay. So we reject the null hypothesis that stationary siya, tama, no? Ito. So tama sa KPSS, so wala tayong problema sa KPSS. Ito, ayan, 0.0146, 0.463, so tama, no? We fail to reject the null hypothesis that our DAP is ano. I think tama na yung mga ano ngayon, no? Tama na yung mga values. Kanina magkaiba tayo. Yan, thank you. Sorry sorry for the mistake, no? Log pala yung ano. So, kanina, ibig sabihin hindi nag-amin mo kanina. Alright, so, dito na tayo sa, punta na ako dito sa ARIMA, no? ARIMA ng DAP, ARIMA 100. So, ang equation natin is, tama na ba, class? 0.3037 na?
Yes po, sir.
Okay, sige, good. So, dapat 0.3037 at saka 2.37. So, this should be 2.37. 2.37 at saka yung AR1 component natin is 0.3037, control C. Okay, thank you for pointing that out, class. Control. Okay. All right. So, yan yung AR natin,
Yes,
no?
sir.
Okay, good. Man, we're on the same page now. Okay, ngayon, pag ano naman, let's see if it's, tanggalin ko na to. If it's another trial class, what if it's, ano nangyari dito? Dollar. What if it's MA process, MA1? So here, I'm doing ARIMA 001. No? 001, wala nang difference kasi DAP na to no? Diba? Naka-difference na yan. So, same thing, ARIMA, and then ang order natin, 001. And then print natin, so we get this, no? So, copy na lang natin to. Control C. Control V. Okay. So DAPT is equal to, take note, this is, ang layo ng pinaglagan ko. Mali. Control X. Dapat dito. Dito. So ilalim dito. 001. Here. Okay, so this is now my 001, my MA. No? So meron akong 0.4012, Control C. Nakay ko muna itong intercept, Control C. So this is the intercept. Para mali yung kanina. No? Mali yung kanina class ha, paki-correct na lang kasi ang na-multiply ko dito, dapat ano siya, 0.037 times ano. Ito mali ito ah. So this should be 0.3037, di ba? 0.3037 times. And this should be 2.37. Tama ba? Oh, kasi yung intercept natin yung 2.37. Okay, just take note class of the correction. And then here, 2.4213. So this is 2.4213. 2.4213. And then plus. So, kailangan mauna tong plus epsilon sub t plus 0.4012. Control C. Okay. All right, yan. Okay. So this is now your DAP sub T pa rin model natin, no? Yung difference ng airline passengers is equal to 2.4213, which is your intercept plus your error term plus log 1 ng error term. MA component to. Right? Okay. Yeah, thank you. Yeah, thank you, Vic. Thank you, Jerome. All right. So I hope class clear, no? So kahit anong model plan, pag alam niyo yung concept, alam niyo yung paggawa ng equation, you'll not get lost kasi alam niyo na yung alam niyo yung pag-generate ng equation eh. So what we have done so far is we did an ARIMA 100 and an ARIMA 001. Now between the two, sino yung mas maganda? Sige nga please. Between the two, who is the better model? Any guess, class? The answer is, which is the better model between the two? ARIMA 100 or ARIMA 001? Okay, the better model is ARIMA 001. Bakit? Mas maganda si 001. Bakit, class? Dito papasok si Akaike, di ba? Ang Akaike ni AR1 process is 1403. Ang Akaike ni MA1 process is 1398. The lower the Akaike, the better. In fact, if we take a look at the others, yung Ramsey, for example, 31.51 to, ito, 32.04. Diba? So in terms of the other metrics for the residuals, root mean square error, mas konti yung Ramsey ni ARIMA 001. Okay, questions, class? Clear so far? Bilis ng oras. Sige, abot po tayo. Any questions? Paki-chat na lang kung clear so far yung difference, which is the better model, yung ARIMA 001 or ARIMA 1, AR1 or MA1. Okay, thank you. All right, good. Okay. Now, paano kaya tingnan pa natin kasi nagta-trial and error tayo. Gamitin natin this time let's use si ARIMA 11. Yan, ARIMA 101. ARIMA 101, ARIMA din ng DAP, ang order niya 101. Okay? So, I'm going to run this. So, see. Copyin nyo na lang, class, nasa taas, no? Babaguhin nyo lang naman, 101. Lag 1 ni AR, lag 1 ni MA. Walang differencing, no? Kasi naka-difference na to eh. Right? Run natin to. And let's see. Oh, yan. May AR1 component tayo. May MA1 component. And if we compare it with the MA1, 1396, 1398 to, no? So which means mas maganda tong AR11, no? Kasi 1396 to eh. So let's write the equation. Control C. Okay, let's write the equation here. Control V. So our intercept is 2.4. Select ko na lang. 2.4509. Okay. And then we have here, copying ko yung dito sa taas. This one. Control C. I'm going to copy the AR1, Control D. So that's ano siya? AR1, negative 4767. Negative 0.4767. Okay. Tapos, then plus your error term, okay, epsilon sub t, plus the error component and a component 0.8645. Control C. Control D. There, okay? So this is our ARMA 11. Meron tayong isang lag 1 ni AR. We're modeling our time series based on lag 1 value of itself. And meron tayong lag 1 ng error term niya. Okay, let me pause for a while and allow you to catch up. And kindly chat, please, if you're able to follow along? Kung okay na, kung na-generate nyo na si ARIMA 11. Okay, good. Thank you. Thank you. Sige, yung iba, please.
Jerome, can you send me your RMD? No copy of that.
Sorry? Saan ba yan?
Sorry, sir. Na-disconnect lang po ako.
Okay. Okay, how about the others, class? Comments? Clear ba so far? Kindly feedback naman kung yes. Kung nakakasunod dito sa ARIMA process natin. Okay, good. Good, thank you. Thank you. Okay, so that takes care of an ARIMA 11 process. Pero, ano ba talaga yung magandang process? Kasi so far, mas maganda si MA1, di ba? Tapos mas maganda pa rin si ARIMA 11. So ano dun? Ano ba? Baka ARIMA 5.1 yan, di ba? O ARIMA 5.5. We don't know, no? Kasi hanapin dapat natin optimal solution. Dati yun ang ginagawa namin. Manualize, no? Pero ngayon, class, buti na lang may auto.arima tayo. No? Yan. Take a look at this. So let's create this object, ARIMA. Let's call it ARIMA_best. And we can make use of the auto.arima function. And then here, ang minomodel natin si DAP. Tapos, lagyan natin trace is equal to true. Okay, so i-run natin to. Okay, so let me for the benefit of everyone, para mas mabilis. Baka nasulat yun na nga. Okay. So let's run this, ARIMA best, auto.arima. DAP trace is equal to 3. Run natin. And R will come up with several models. Okay. And with drift, pag sinabing with drift, with constant yan. Tapos yung iba walang drift. And it tells us that the solution is ARIMA 201 010. And then my 12. Okay. Ano to? Ano to, class? Okay, this is something that we are meeting for the first time. Bakit may pangalawa dito? So yung una dito, class, is your ARIMA PDQ. PDQ. This is the regular component of your ARIMA. Yung pangalawa dito, capital P, capital D, capital Q. This is the seasonal component. Kaya nga may 12 dito. Ayun. So, ibig sabihin yan, may seasonal component yung ano natin, yung model natin. And it makes sense kasi may seasonality siya, seasonality siya, di ba? So, R is telling us that our best model is an ARIMA 201 01010. No? Ibig sabihin, i-difference pa. Ayan, no? Tinan ito, no? I-difference pa siya ng lag 12 kasi sa seasonality na 12. Okay. Sige, gawin natin to, class, no? Let's do this. Okay. I-clear pa muna yung drawing natin. Let me pause for a while. Did you get the same answer, class? 201 010 and then 12. Do you have this answer also? Then if you take a look at 201 010, ito yan, 201 010, ito, no? Infinite yung ano niya, yung ibig sabihin, okay, with drift kasi ito, no? 201, asan yan? Hanapin natin 201 without drift. Kasi walang drift yung ano natin, answer natin. This one, 201 010. The akaiki is 1018.166. So among this, ito yung smallest na akaiki na AIC. Kaya ang sinasabi niya, this is the best solution. Smallest na AIC. Akaiki information criterion. Okay. Alright, so, sige, i-model na natin to, no? Before that, kasi ito, yung trace is equal to true, para mabilis niya ma-generate yung answer, ina-approximate lang niya. So to really get the solution, gawin natin to, no? Copy nyo and then approximation is equal to false. Ibig sabihin, no, we will ask R now to generate the solution na hindi niya ina-approximate. Okay, so run ko to. Okay, iti-trace pa rin niya. Pero this time, it will take a bit, konti lang naman longer, no? And then hindi naman nagbago. Yung pa rin. Yung pa rin. So the best model is still ARIMA 201, 010, and then 12. Okay. So let's do that. Okay. So ito na ngayon class, no? Mali ito. So kanina kasi, hindi naman nag-complain yung yung kabilang section na na iba yung data namin. So ARIMA 201, 010. So ARIMA DAP order is 0. So this should be 2. So ito yung regular component. Tapos dapat ilalagay natin dito. Seasonal component is equal to list. Order is equal to. Yung L dito, ibig sabihin integer lang naman yan. So you can put L here. Pwede naman. L. Ibig sabihin yan, di ba, integer. Plus L. You can put L there. L. So ito dito, 0, 1, 0. Okay? So I'm calling it ARIMA 201 underscore 010. Okay, summary ni ARIMA. Summary natin, 201, 010, and then 201, 010. Yung coefficient niya, no? Dollar coefficient. Okay. Lalabas din naman dito yan. Okay, in the interest of time, ano ko na sa inyo to, Control C, chat, Control V. There you go. Okay, so I'll run this. Okay. Yan. So ito na class yung AR1 component natin. Ito yung AR2 component. And this is the MA1 component. So our equation will be DAP sub T, hindi ko na isusulat, bahala na kayo magsulat, is equal to 0.596 times DAP T minus 1, and then 0.2143 times DAP T minus 2, and then plus epsilon sub T, and then minus 0.9819 times epsilon sub T minus 1. AIC is 1017, definitely higher than lower than the, compared to the others kanina. 1017, ito 1396, di ba? Mas mababa talaga itong na to, itong model na to. Yan. Okay, so that's the best model. In fact, also yung RAMC niya 10.884 if you compare it with the ARIMA 11 kanina. Ito 32 di ba? 30. Okay, so definitely better yung last model na to. Okay. Now, let me just quickly discuss, no? It's okay, it's almost time class, but those of you who need to go, okay lang, no? Para ma-record lang, no? Okay. Now, I just want to discuss, okay, kasi ang sabi niya, di ba, may seasonal differencing. Okay, what if, i-difference ko ng okay, mag-create ako ng isang object na seasonal differencing, SDAP, so that it will be the difference of my DAP, ito difference na to, di ba? Pero this time, isi-seasonal difference ko siya ng 12. Log is equal to 12. Okay? Okay, ito muna class para, no? Paano yung auto.rima? This time, gamitin ko yung original data, no? AP. Ano magiging solution niya pag nag-auto.rima ako? Control A, answer. And take a look at this. If I'm using the original data, ang answer ito, 211010. So ano ibig sabihin nun? I-difference mo muna si AP. which is what we did a while ago, di ba? So, kahit na gamitin yung class yung ano, yung original data or yung unang difference, it will still give you same answer pa rin to. Ito pa rin yun. Sasabihin lang niya kung anong i-difference mo. Okay? Tapos ito naman class, ito, di ba nag-difference sa yan? Ito, so here, mag-create ako ng isang object na SDAP, which means seasonal difference, which is the difference of your log1 difference. Magdi-difference ako ng log is equal to 12. Alright? So here I'm creating SDAP seasonal difference, and then auto.arima SDAP. Okay, let's see what happens to this solution. Okay. Take a look at this. Tingnan yung solution. The final solution is ARIMA 201. Okay, nawala na yung seasonality component ng differencing kasi dinifference ko na siya, di ba? Okay, so it's 201. Natanggal na yung ano, yung second part dito na seasonality component kasi nag-difference na ako. Tapos ito zero differencing na rin, di ba? Yung regular differencing wala na. And what's the solution, class? It's the same. Ito pa rin yung AR1 component, AR2 component, and FA1 component. Okay, exactly the same. And the AIC is still 1017. Okay? So, whatever data you use, class, for your modeling, ma-detect ni Aryan kung mag-regular differencing siya at siya mag-seasonal differencing. Okay? And it will give us the same solution, whether you differentiate or whether you use yung data nyo na hindi pa na-difference. Okay? So just take note that dito class, ang model na natin, SDAP na to. Ito. SDAP na to. Yung kanina naman, yung sa AP ang ginamit natin, ang result, SDAP pa rin yun. Kasi ang sabi niya, difference yung regular, one differencing. Yung seasonal, isang differencing din yun. Okay, SDAP din yun. And you get the same answer. Ito yung final model natin. Okay. And finally, class, titignan na lang natin to, no? Kung how our model looks like. Bigay ko lang sa inyo to. So this is, muli lang 2. 201. Okay, so this is ito di ba yung yung sa DAP to let me just show this to you, class. Time series diagnostics. Send ko sa inyo to, no? Ito yung modeling. Ito yung natin, DAP. Kasi ito yung di ba ang answer lang sa DAP, 201 and then 010. May may ginawa ba natin yan, ito, this one. Right? We did this. Tapos, let me share this with you. Control C is for you to copy. Chat. Control V. Okay, paki-copy na lang siya, class. And then, when you run this, okay, tingnan nyo. Alright? So first here is that and let me just end in this. Sorry for a little extension. Ito muna. Okay, tingnan nyo, class. No? Tingnan nyo residuals. Tingnan nyo yung ACF. Diba? Ano to? Wala nang significant, diba? White noise na to. Ibig sabihin, yung model natin was able to capture yung natin, yung variation ng natin. No? P-value, okay, yung box test. Okay, and then also this one. Okay, so diniscuss natin itong yung back test, di ba? So ano ba yung tinetest yan? Check nyo na lang. And then this one, take a look at the residuals. Our residuals are okay. Okay, dito sa ACF natin, may konting lags lang dito na ano lang ito. More on surrounding off na yan, kaya ganyan yan. And the residuals are quite normally distributed. So our model looks okay. White noise, ibig sabihin ng class, wala na mga significant na correlation. Okay, that's what we mean by white noise. Ito. Ito, tinan nyo to. Yan, no? And sorry for not explaining. White noise na yan. Yung ACF natin, at saka yung PACF natin, pag prinat natin siya, notice na wala na siya mga significant spikes. Wala na mga significant na auto na correlation. So which means, class, that this is a good model. Yung ano. Ngayon, na next meeting, pag-uusapan natin si Garch at si Arch kasi pag financial time series, hindi magiging ganito. Kahit na mag-ARIMA tayo, makikita natin na may mga significant spikes pa rin, may mga volatility. Okay, so that will be the subject of our lesson on Thursday. Okay? Alright, so kindly review na lang to, class, and then, and lastly, tinan nyo to. Okay. Di ba kasi yung AR natin, 2, di ba? 2, di ba? 2 yung log ng AR natin. Look at the solution. Hindi siya unit root, di ba? Pag unit root kasi, dapat nasa circle siya. And it's outside the circle, no? It's inside, and it's not on the circle itself. So, ibig sabihin, okay itong solution natin to. Yung MA natin, yung medyo malapit, no? Kaya 0.9 almost 1, no? Almost 1 yung MA natin. So medyo, although hindi naman siya eksaktong 1. No? Kaya ito yung sinasabi natin na unit root test. No? Plus, pag ando dun sa circle na yan, ibig sabihin the solution, may solution na correlation rho is equal to 1. So which will make our model, our time series as not stationary. Ito, malapit, 0.9 kasi yung ano natin. But we'll discuss this on Thursday. All right, thank you so much.
Thank you, sir.